And I should take the attendance first because this is the students. After that, I think I'll not join. Okay, this slide is visible to you. Cache performance matrix is visible.
No, sir. No, sir.
Not yet.
Not yet, sir.
Not yet. Okay.
Sharing the screen.
Yeah,
Yes,
yeah,
sir.
yeah. Just 1 minute. Now it's visible. Is
Yes,
it?
sir, now it's visible.
Yes.
Yes.
Okay. So it's visible, and then we can start it again. First of all, we would like to point these things that three things you should remember in the analysis of the cache performance. Whenever any competition, mathematics or theoretical concept is coming, particularly for different examination, you just remember that in cache concept you will find these the 3 points. What are the 3 points? First is miss rate. That means whenever CPU sends the instruction to the cache memory, if it is not found, then it is go to the main memory. That is the always our concept. Okay. So initially you just remember one point, that when your computer starts from very beginning, that is called cold booting. You know cold booting? Cold booting, that means first start the button of the computer. When computer is gets ready for working, that system is called cold booting. And warm booting, already is the system is working, and maybe due to some troubles, or maybe you have to go some update or something, you restart the computer, that some warm booting situation is coming. I think this is class 5 standard, you know it. So in particularly cold booting, after the cold booting process, or maybe after the restart the system machine, there is no content actually the cache. Only the main memory part is loaded with the basic operating system, which is required for your minimum tasks initially. And day by day, when sorry, not day by day, in course of time, when CPU requested some papers or pages, automatically main memory load this from our secondary memory or other storage, and from corresponding main memory to cache memory. So you will find in the caches a compulsory misses. One condition is called compulsory misses. When I will get the compulsory misses, that means you must get the miss rate. So fraction of memory reference not found in the cache. So can you tell me in which situation you will every time find the compulsory misses?
Sir, in case we are searching for something for the first time, like
First time. And generally, you know that after the cold booting process, there is no content on the cache. There will be no content on the cache, or in the very beginning, when first process you are start to executing, I think there will be no nothing in the cache. Am I correct or wrong? So you will get first time a cache misses there, and that is called compulsory misses. This will every time happen whenever you are getting to access a page which was not accessed earlier. You will get first time miss, and generally it happen after cold booting. After the cold booting, there is no content on the cache, so you will get compulsory misses. Okay. And you find that 1 minus heat rate. You remember, I am not telling heat rate. So actually heat rate you can, so always we find the heat ratio. Heat ratio for a particular process or particular time duration, you can compute that for the particular cache, that whenever you are trying to access a cache memory, and suppose you are accessing within time t delta time, you are accessing 100 times. Among 100 times, you got certain pages, not pages, certain pages, maybe few pages, maybe 20 times you got, and rest of the thing among 100 access. So your heat ratio become that time 0.29, or 90 times you got the page, so heat ratio becomes 0.9. Did you get my point? And 1 minus 0.9 will give the your miss ratio. That is the our point. So typical number in percentage can be quite small depending on the size of the cache. Again, the size of the cache is very important. Heat time to deliver a line in the cache in the processor, include time to determine whether the line in the cache. So whenever you are searching a page, you have to search in the cache. So this is the very important point, that you are searching a page on the cache, and during the searching it may happen that you did not you get the page. So actually heat actually heat time is there during the searching of the page. Whenever you are searching, a fraction of time is required to get the page. That's why I'm telling that time to deliver a line in the cache to the processors as well as the time to searching the space. So whenever you are searching the space, particularly in the cache memory, you are searching a page space in the cache memory from the CPU. So you will return to the CPU also. Okay, you will return the content of the CPU also, as well as to the cache memory, because so many locations will be there in the cache memory. Some search time will be always there. So this time and this time total will give the heat time. So time to deliver a line in the cache. Remember, time to deliver, that means including the search time also. Typical number 1 to 2 clock cycle for L1 and 5 to clock cycle for L2. That is the level of the cache as well as the size of the cache as well as the speed of the cache. And I think miss penalty, yesterday I discussed that additional time required because of the miss. That means when it is found, because searching in the cache as find is the time is lost, then it will go searching in the main memory. So again main memory searching time, then plus from main memory to CPU, that time. So all these things will together give you the compute the miss penalty. So additional time will be high in case of miss penalty. Okay, so that is our one point. Then you will get the performance heat plus miss with the total CPU references. That is the one very important point. Heat ratio is always the heat by heat. The total CPU references the number of total access. That's I mentioned you. So always heat ratio you'll find heat ratio equal to number of heat the page is found by total number of page access. That is total number of CPU reference. Very important for your mathematical calculation formula. Average access time of the memory system. Now remember that is the average access time. That is another very important parameter. When you are going to calculate or you would like to estimate the performance of the particular memory system, always judge with the average access time. That means maybe say a cache is fast or slow, main memory is fast or slow. You can judge with this level. So average access time in memory system consists of two levels, main memory and cache, because initially CM and this is the MM and this is our CPU. I told this part earlier. Okay, like in this way.
Sir,
So two level, yes.
sir, total CPU reference is always 1.
No, it is number of that means time you are accessing. It may be 100, 10, 20. For a particularly process, there is maybe 10 pages, or you would like to access 10 times each pages. So that time total number will be 10 pages. Among the 10 pages in the cache, you may found two, other 8 is not found. So at one time you get the two that calculate. I'll give the mathematics also, but total CPU references is heat plus miss, not heat ratio plus miss ratio. Heat ratio plus miss ratio will always give 1. Did you get the point? Heat ratio
Yes,
plus miss ratio will give the 1, but heat plus miss does not give you the total CPU reference, does not give 1. It is the number of time you will access. It depends upon the process and depends upon the number of pages for particular the process should be required. Is it clear? But the question is that when you compute heat ratio plus miss ratio, that time ratio, I'm telling the ratio part, that time it is always 1. Okay, that's
and
why.
sir, rate, sir, and we will use when rate, then it also be 1.
Yes, heat rate, if you consider the number heat rate, that means the divided with that number of CPU references, that time only. But total CPU references is that the number of time you are accessing the cache memory or the total number of pages required to access during that CPU or executing a process. Okay. So that is number of pages depending on the process size, page size, or you can say the whatever process running at that time, and that needs how many process to pages to be accessed. So that is difference value different for each process. Yeah.
Yes.
Any doubts? Okay. Now Average access time for any memory system consists two level. If TC is the time to access time of the cache memory, TC time access to the cache memory, and TM is the time to access the main memory. That time you can write average time to access a particular memory, heat time into your cache average access time plus 1 minus heat, that means miss. If it is not found, then miss, into, you will find here I am writing two things. What are the two things I am writing? TM plus TC. Why TM plus TC? Why TM plus
Sir,
TC?
because after getting a miss from the cache, then we are going to
Yeah.
the
TC
main
is
memory.
required, that is not found, then you will call the main memory. So that's why TC plus TM. Be careful, it is hierarchical. It is the hierarchical way I am doing. The hierarchical system. That means initially first you go to the CM. If the page is not found CM, then you will go to the main memory. Only these cases we are considering these things. But sometimes you will find some caches when multi-level caches are there, parallel you can search. Okay, that time this concept may not be applicable. Did you get my point? Did you get my point or not?
Yes, sir.
This is hierarchical concept only for cache and main memory concept. The multi-level cache memory, this concept will little bit differ. For the time being, you just point to be noted. So see, in these cases, if H1 and H2 are the hit ratio of T1, T2 are the access time of L1, L2 memory. I don't know that L1 and L2 are here. You just notice it is serially connected, or you can say hierarchical. Okay. You know hierarchical concept like a tree structure concept. First root, then subtree, then subtree's child, like in this it is going. L2 cannot be accessed until L1 is not finished. If L1 is finished, okay, if L1 is finished, you will find that if L1, you will find no data is there in the L1. Okay, no data is found in the L1, then it will go for the L2. But in these cases, you notice L1, L2, L3 all are in parallel. Am I according to concept? All are in parallel. That's why initially heat ratio into T1. My dear students, listen carefully because lot of mathematics will come from this view. First of all, you notice it that if H1, H2 are heat ratio of T1 serial access time. So here heat into T1, that means searching time to get the value page 1 from here, H1 T1. If it is not found, then you go to the L2, that it is not found. It is not found. That's why heat time of home, heat time of L2, then additional time is T1 plus T1. T1 for what? This one searching time and the one T2. Like in this way, plus dot dot dot, you will find that 1 minus maybe Hn minus 1. Am I correct? Star dot dot dot, you will find here up H1 into sorry, here Hn into, you find T1 plus T2 plus T3 dot 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 up to T3. Did you get my point? For the last values, like in this way, you'll get the average access time for entire this part. This is the average access time for entire this section I am telling.
Sir, this formula and the previous formula are different.
Which formula? This formula?
Sir, here we are taking H1, H2. In the previous, there was only H.
See, the difference I am telling that.
It's the same concept.
Yeah, no. I am telling that this is the heat ratio. The first one come to the point here. In these cases, I am found that H into heat ratio into time minus miss into this, and miss ratio for only cache and main memory. This concept cache and main memory, two levels only. Here only two levels. Okay, but if you not restrict your two level, we are going for multi-level memory access time. So in multi-level memory time, that is a miss ratio. I don't know that this page may not found where you will go there also. In earlier case, it is stopped here. So that's why my search will finish here. But here after that you will go. That means there also hit or miss. In earlier cases, only hit or miss in the first levels, and next level I will consider EL found error. Got my point?
Oh yes, sir. This means H is 1 for the previous thing.
In previous cases, cache was only hit and miss, and last case if it is not found the cache in the main memory, you will found it. But here is a multi-level memory structure. If hit and miss, here also hit and miss, at the last level, I think at the last level, ln, you will not give hn. That part will not be there. In the last level, no hn will be there. Because we will consider that it will be there. Got my point?
Yes, sir. Yes, sir.
Yeah. Okay, thanks. This doubt should be clear. Very nice question, because sometimes in the question you may be doubtful regarding parameter. But in these cases, you see parallel. So here the interesting there, heat of the first one. If it is not found, that means miss of the second one. And second one also again hit and miss. But remember that here I am not writing T1 plus T2. Why I am not writing T1 plus T2?
Sure, because it's happening
Because
parallel.
parallel searching. Parallel searching, if page is found, the searching is not useful. This searching is not required. So this will come when this miss will happen. That's why here T2, but here is T1 plus T2. Okay, understood this point? So in parallel level, and this is the in say sequential level, or you can say hierarchical level, only difference is that the time computation is high. So in some architecture they follow this, in some architecture they follow this. So this is the one thing. Now, if it is not found the cache misses, that is called first. What are the different type of misses? Compulsory misses. That's why I mentioned cold start or cold booting or process migration. This is the first reference. Fast access for any block, you will get that compulsory misses. Suppose you are running process A. Process A you are now running at this moment. Sorry, process A you are not running. Suddenly you will feel that I will run in now process B. So all the process pages, blocks, which will fetch from main memory to the cache memory for process B, initial access, there will be no pages of the block. So you will get the compulsory misses. Or you can say, whenever any first reference to any pages happen to the cache, first reference will be compulsory misses. That's why this point to be noted. First references of any pages is always you will get the compulsory misses. Is it clear? Cold fact of life, not a whole lot you can do about it. If you are going to run billions of instruction, compulsory misses are insignificant, because sometimes some after the first references day by in course of time, when the pages will be again accessed, so no more further loading is required, so automatically the compulsory misses will decreases. That's why it becomes insignificant. Is it clear this point? So this is the cases of the compulsory misses. Another part is that capacity misses. So capacity misses is the another important parameter. You will find that cache cannot contain all blocks. It is a true fact, because as per the main memory size and the requirement, cache cannot contain all these pages. Increase the cache size. Is that you have a cache memory where only 4 blocks at a time you can give. Block 1, block 2, block 3, block 4. What will happen? You have to access block 5. Then again you have to load it. Suppose a process B have 10 blocks. But all the blocks cannot be loaded in the cache, because only 4 at a time it can occupy. Are you getting my point? So my requirement does not fill up. So cache cannot contain all blocks accessed by the program. So you have to increase the cache size. So it is a capacity miss. That means my requirement not places. Conflict misses. Conflict misses and capacity misses, these are very important parameter. Just remember that due to the mapping policy. Actually, it is happened due to the mapping policy. The conflict misses happen. Conflict misses that even cache space are free. We have considered that the page where it will be loaded, the page reference number or page number modulus of cache block number, total cache block. Suppose your page number is 8, modulus operator, how many blocks are there? 4. What is? Remainder is 0. It is the remainder operation. You know modulus means remainder. So remainder is 0. So page number 8 will be loaded on the first location 0, 1, 2, 3. When you are going for 9, it will be loaded 9 by 4 1. So it will be loaded in the first location. When you are going to 10, it will be loaded here. When you are going for 11, it will be loaded here. Now come to the point 12. Where 12 will be loaded?
In 0.
0 location, but already the page is occupied by some other pages. So you have to replace it. So for that particular pages where he has to go, actually should be empty, but it is not empty. So that's why it is conflict misses happen. So if your page reference is like 4, 8, 12, 20 and 4 break cases, that I think all these page try to go in this location. That's why compulsory misses will be given. So possibility sizes, increase the size, cache size, so automatically we can decrease and increase the associativity. That I will discuss in my mapping policy. Another is the cache coherence. This is very latest of the other process updates memory. Cache coherence you try to understand. Generally it happen for server side or where multiple copies of the processors are there for the cache coherence happen. Suppose you have a shared memory in server architecture, that is shared cache. It's called shared cache because our number of core CPU may be more, C1, C2, C3, all are CPU, but different core, you know, quad core, dual core, multi core, so many architectures are there, or with 6 core, hexa core, like in the different core, and each of them has some individual alone cache, suppose. So in shared case, some X data is present, and you take the data by C1, C2, and C1, suppose. Suppose you are now updating the value x2 x plus 1 and you have updated the content here instead of x plus 1, then what will happen? They are not getting that updated value here. Getting my point or not? So sometime by using so input also you can update the content. That's why even all are x, but some individual processes update the content. It is not integrity of the process not maintained, then cache coherence problem will happen. This is a very modern topics in modern advanced architecture. Cache coherence is found.
So basically updates have happened, but they haven't completely registered in the cache. That's why the miss happens.
No, when it is happen shared cache, shared memory, when some locations are shared among multiple processors, and this situation will happen. In single processor architecture, it does not happen.
Okay, sir.
In single processor only happen if already some process you are running in a single CPU that is executed by this location, and that location you trying to modify with other location, and CPU does not aware of this thing, so you will get some, when you are going to update some value there, you will get some wrong information. So data integrity will not be maintained. So that's why I mentioned other process like input output updates the memory without having the concept to the cache. And that means cache is updated or not, because write back and write 3 policy is the only thing. So that time cache misses happen. Now we are going for the mapping. That is the very important policy. That means you have a main memory. First of all, I would like to go my whiteboard. Whether it is visible or not, you tell me. Then again, I will come to the cache. Is the whiteboard visible?
Yes, sir.
Yes, sir.
Okay. Suppose you have some cache memory. So this is the cache. This is the main memory. Suppose 0 to 63. Here 0, 1, 2, 3, 4 blocks. In cache location we call it blocks. In here we will call it frames. Astonishingly, when main memory and secondary memory consider will be there, that time the concept of the page will come. Okay, so page and frames are nothing but only the memory location. But when in case of secondary and main memory, we will consider page. When frame will consider from this situation. We will consider block, ID and cache, block, main memory, frame. Okay, but when you go to the secondary memory or main memory, we will consider this location individual page. Okay, so that is the only the different versions you are considering for your purpose. Okay, so no need to think about this. For time being, you consider that we are using frame and block. Okay, so here is the frames. Is it visible to you? Okay, now what happened that I know it has some pages are there, and at a time one page, one block, how many blocks you can present? 4 blocks. Which 4 will come here? 0, 1, 2, 3, like in this which page? So number of cache blocks is a number of cache block. I writing C block and the block frame reference. Take the module operation of this one. So in frame reference, suppose 56 module operation of 4. What is the location is coming? Remainder. What is the remainder?
Sir, 0.
What is remainder? That means if earlier 4, here only 0, 4, 8, 12, like in this it can present. Am I correct or wrong? Am I correct or wrong?
Yes, sir. Yes, sir.
Only these pages can be present. So from the cache memory, you will find here is the many location. How many location? Many location. From many location to 1. Am I correct? One location is shared among many locations. So it is one to many concept. Can I say it is or not? One
Yes.
particular location is can be used by, I can't say shared, can be used because at a time only one page block can be present. Either 0, either 4, 8, 12, like in this way, up to maybe 60. Any one of these pages can be present here. Okay, so it is coming that one to many function like, and 4 never will go this location, even these are empty. Suppose you are referring the page 0, 4, 8, 12. First 0, it will come to the first page. Am I correct? It is coming to the first location. Now your action is 4, again it will come here, 0 will replace, 4 will stay there. Am I correct? Again 8,
Yes,
8 will come here, 4 will replace here. Even you found the space is there. What type of misses are happening here? What type of misses?
Sir, the capacity misses are happening here, sir.
No.
So it's a
Capacity, how can I say?
conflict misses, sir.
Conflict is a conflict. So conflict misses happen here. So it is that you can say a particular page from the cache, it is coming that you can write like in this way, a particular page, or we can say the frame will be mapped to a particular Or you can say definite, not particular. You can say definite. Definite cache block only. Am I correct this point? If your hardware configured in such a way that I can say this is nothing but, generally you can say this is called direct mapping. Why direct? Now it is clear. Because it is called direct mapping because we never find that 0 will stay here, 4 will go there. No, they will take the same individual one location. So that's why it is very important to all of us to understand that what are the drawbacks and what are the advantage of direct mapping. Okay, what are the advantage of direct mapping? You should understand. First, understand that I think load and store architecture, if I follow, I think time will be less, timeless. Why? Because a page had to be loaded, it is fixed. So you will only search that location or you will go to the particular location. So loading time for a particular variable from main memory to cache will be very less. Also, whenever you are searching in the cache particular page, if it is direct mapping, so directly you will go to the location instead of multiple searching, because you know this will be available here. So you will get always searching time will be very less. Am I correct or not?
Yes, sir.
Searching time will be very less for this one. So this is the one very important point for this one. So direct memories, this is the best advantage we receive so far.
Sir, one question, sir. Sir, is
Yes.
another advantage of direct mapping also that conflict misses won't happen?
Conflict?
Misses won't happen, sir.
Conflict misses, generally there is a chance to be happen if you are accessing the pages which will take the same location of the cache block.
Okay. So direct mapping will have might have conflict misses.
May have, or there is a chance we get the conflict misses.
Okay, sir.
Okay. Each block of main memory maps to only one cache line. This is correct. If a block is in cache, it must be one specific place. Address is in two part. So you will get two-part address part. If you had generated the CPU address, so you will find actually page location and that is the page offset. That is the main thing. On CPU always tries to access the page. In the page location or page location, we will part two part. One is, you can say that I am mentioning here in the cache blocks, and one is the tag. The whatever the main memory's address will be divided into tag and cache block. I will come to this point here. Address is in two part. Least significant W bits identify unique word. Most significant S bits specify the memory block. So within the block, I will go for the page offset. So you are just getting like in this way, M and W. W is the offset, frame offset. That means within the page, we can for location. So first of all, you have to go within the page, that is the main memory M below, in which location it will be present. And getting after getting the location, which value I will access, that depends upon the W. Is it clear or not clear? Very important part.
Yes, sir.
Is it clear this point? First is the M, N for W, because in context of physical address, whatever CPU generated, it is directly associated with the main memory. That's why we always call, if main memory is 8 GB, it can support at least our 64 GB of OS system. That means 2 to the power 64, whatever address it will occupy, at least some pages, at least one pages it can store with the 8 GB RAM. So you will never get any doubts in this parameter that in direct mapping, two parts are there. One is main memory, one is the we block offset. Main memory address to get the location of the main memory and offset from the location in the individual location. That's I told you here. If MSBs are split into cache line and tag, when you are getting the main page, that is the M part, N part we are dividing two part. One is tag, another is the cache block. Because a page will be now mapped to the cache individual block. So when we are mapping to the cache, cache has some block number. So you have to get the block number and corresponding to the, you will get the tag for comparing. Okay. With example, we will analyze it. This is the architecture actually follow. Whenever CPU generate this address, actually CPU generate this address. You notice the architecture internally what happened, because most of the time you always get this part only. Because if underlying architecture not clear, then how you can solve the mathematics? That is the main problem. And I every time telling you, I will teach lot of theory in the classes, but in the examination you will find all our mathematics and mostly architecture. Why it is advantage, what is not advantage? In context of the organization architecture point you have to answer, not directly you write some Ramayana and Mahabharata or whatever you learn from your internet sources or write the theory. Maybe it's my personal opinion, I dislike always to write, cram and write. But if you understand, you can write. So that's why try to understand. That's I told you that this is the entire part we will call it as a M, or here it is mentioned S. Okay, S for source and W for the word width. Okay, suppose earlier days no cache was there, so this part was not there. What will happen? Directly it will go to the main memory. Am I correct or wrong? So this is the main memory. Our target that from the main memory, I have to store in the cache. Is it clear? So in the main memory, how many blocks I can take at a time, that depends upon the cache block size. Okay. Sorry, cache line. One thing I have skipped this portion. In case of just for time being, I am telling you, in the cache part, we will call it a line, and in the main memory, we will call it a block. Is it clear? In cache part, we will call individual location as a line, and main memory we will call individual location as a block. It is for cache and main memory. When you will go to the main memory and secondary memory, in secondary memory it will be a frame, it will be a page. Am I clear? Okay. A page will be loaded to the frames of the secondary memory. Here will be a block of the main memory will be loaded to the line of the cache. So how many lines will be at a time, they are define the block size also. So whenever you compute cache and main memory, you just remember a very important pair, block size. If block size information is not given to you, you can't solve any parameter. Try to understand this point. If any data of the block size not given, you can't solve any problem. Is it clear, this issue? So some question will be given and the block size is not given. So automatically you try to understand that problem cannot be solved. You just directly write, since block size is not given, I can't solve this problem. Can you write these things? Can I write or not? Because block size will help us to define at a time how many lines will be loaded from the how many blocks of the cache. So block size is the very important. Here block size, how many block size is given? 4. So suppose this mathematics is coming like in this way. So I am writing like again. So very important parameter is that block size. Try to understand. Now address length is S plus W. The number of addressable units 2 to the power S per W words per byte. Block size is equal to line size. That is the very important parameter for our computation. That is we return 2W to the power W words per byte. The number of blocks in main memory will be total main word size per block. That is the number of block. Now number of block, if you divide with the cache line only that time you will get. Suppose number of lines in the cache is m, and that is the to the power r. So that is the issue. The number of that means size of the cache will be 2 to the power 2 to the power r plus w, or you can say that means number of block can represent, you can find out like in this way, number of lines. Okay, so number of blocks in the main memory will be the total CPU address by the block size. Automatically you'll get that one, that is 2 to the power s and 2 to the power m. So I am writing 2 to the power in the lines of the cache. One mathematics will solve, you will understand it. Size of the cache is 2 to the power r plus w bytes, word per bytes, and size of the tag is s minus r. So one mathematics you will solve, then you will understand this point. Let's do one mathematics. Okay. So in direct mapping, what happened that you just notice it that suppose I have a here up to 15, that means 16 blocks are there. How many blocks? 16 blocks. Okay, and each of the block has 4 words. How many words are there? 4 words are there. 1, 2, 3, 4. 4 words are there. So I can say 16 into 4, that means 64 unit memory is there. If it is a GB, then 64 GB or KB will be happen. Am I correct? If the block size is suppose 1 KB, then what is the total main memory size? What is the main memory size?
So 64 KB.
64 KB.
Sir, if block is 1
16
KB,
KB.
then there are 16 blocks.
Block is 1 KB. That means how many blocks are there in particular block? I am
So
telling
4.
block, that is sorry, I am telling that particular word.
Then 64.
That's it. That's identity. If block size is 4 KB, because each of them 1 KB, so that time the 4 KB, then again it will be 64 KB. No problem. That will be very easy to understand. Okay. That means I am telling block size is 4 KB and word size is 1 KB. That means individually 1 byte addressable. So if block size is 4 KB, then total is how much memory? Is it correct? It is 64. It is correct or not correct?
Yes, sir.
Okay. Understood the mathematics? Directly I'll go to the mathematics after this point. So now it is found that each of the individual location is look like in this way. I know 0 can come here, then 8 can come here, 12 can come here. Is it correct? Because it is a many to 1. All these many will be mapped to a particular individual location. That's why it is called many to 1. If you go for direct to cache, actually this no happen because our target then main memory block will come to the cache. So how many locations of main memory is accessing one memory? You found that one location of the cache is accessed by the multiple location at a time. That's why it is many to 1 concept. Is it clear? Is it clear this point?
Yes, sir.
Okay. Now you will find that suppose how many the block number is this one and block offset is this one. If you add these two part, you will get the total block which you are specifying. Number 5. So this is the 5. This is the 5. So in 5 location, what is the block number? 001. You will go to the 001 location. What is the offset below? 01, because 00, 01, 1011, 4 block at a time offset. So what is the block offset? 5. So you will access this value. Getting my point or not? Whenever any address will be generated, you just specify the block size. Because we know what is the block size here? Just tell me. What is the block size? 4. What is the block size? 4 KB? I mentioned or not?
Yes, sir.
Block size is 4 KB. That means within the block, total memory is 4 locations are there. Suppose 4 locations offset. So access 4, I think how many bits are required? 2 bit. Am I correct or wrong? 2 bit. So whenever this address is generated, block offset is 2 bit and rest of the part is the block number. Is it clear? Now, when CPU search, that page is not found, you have to load it. Then it will go to the, according to the main memory, it will go to the this location, and from that location, based on the offset, that will be loaded. So this will be loaded to the particularly 5. 5 will loaded, I think, this location. 5 will loaded this location, because you see its offset value also. Offset value also will help you. You sorry, offset not in main memory. You will separate the cache line and tag bit. So cache line value will specify which cache line it will store. Not clear? Is it clear or not clear?
No, sir.
Not clear. Okay.
No, sir.
Okay, I will come to the point again. Okay, let's see solve one problem. One main memory size is given 128 KB. What is the main memory size? 128 KB. Cache size 16 KB. What is the block size? 256 byte. So 128 KB into 2 to the power 10. What will happen? It is byte. It is byte or not?
Yes, sir.
It is the main memory. So 128 into 2 to the power 10. Now 128 how much? 2 to the power 7 or 2 to the power 6?
2 to the power
7, sir.
7.
Seven.
7.
Sir, 7, sir.
7 and 2 to the power 10. So this is the main memory size. Now you will get the main memory. Now what is the block size? 256. That means 2 to the power 8. Block size 256 means how much? 2 to the power 8. Am I correct?
Yes, sir.
8. So how many blocks will be there? This is the number of blocks. Total memory divided by the block size. Total memory divided by number of block size. How many blocks will be there? So this amount, I think 2 to the power 7 and 2 to the power 10.
9, sir.
Huh?
9.
2 to the power 9.
9, 512.
So 2 to the power 9 blocks are there. That means total 9 bits will be there for 9 bits for your main memory location accessing will be there. Am I correct or wrong?
Yes, sir.
So 9 bits. So I don't know. So total memory size is 2 to the power actually main memory is 2 to the power 17. Am I correct?
Yes, sir.
2 to the power 17. Now you got the address size is main memory size is the CPU address generated. 2 to the power how much?
Sir, can
17.
you please tell how we got the main memory size?
It is given main memory size 128 KB
128 into 10. Why did we multiply 2 to the power 10?
because it is a KB2 byte.
1 KB is equal to 2 to
Oh,
Not clear?
yes, sir. Clear, sir.
Okay. Because block size is given byte na. So it is just like in this way. In a sack, you can take 5 kilo rice in a sack, or in a bag you can take 5 kilo rice. You have a 50 kilo rice. So how many bags are required?
Sir, 10, sir.
Like in this way. So you
Sir,
know
I
this.
actually didn't notice the K.
Okay. Now it is clear. So
Yes.
17. So I think 17 bit is my CPU address generation. That is 17 bit. Is it clear?
Yes, sir.
Among 17 bit, 9 bit for my memory block, MB, main memory block, and rest 8 is for offset. Am I correct?
Yes, sir.
8 bit for offset because it is 256 byte. So individually, if I take 1 byte addressable, like in this way at a time, so 8 bit will occupy there. Is it clear?
Yes,
Is this
sir.
plus clear? Okay. So among 9 bit, now I have to find out the tag and cache line. Is it clear? Now, what is the size of the cache?
So
16
16. So 4 bits for tag and
2
cache
to the
line.
power 4 into 2 to the power 10.
Oh, yes, sir.
First, this is the cache this is my what? Cache memory. And what is the block size? Because this block at a time, one single block will come to the cache. This entire block will come.
Hmm.
So 256, that means 2 to the power 8. Are you getting my point or not?
Yes, yes, 2 to the power 8 by
2 to the power
yes.
8 is 2 to the power
Yeah,
8 is
yeah.
my so it is again 2 to the power 6.
Yes, sir.
2 to the power 6 is the total number of lines. Number of lines in cache. Not clear, na?
Yes, sir. Clear, sir.
Yeah, not clear. ওই তো বলো না আরে हवा में घूम गया फिर से मायरो में जाते ये मायरो चाहिए
Sir, number of lines, sir, I
नाम to
understood that.
नाम पे दो बोलो मुझे मेन मेमोरी साइज कितना हुआ
9 bits, sir.
इतना मेन मेमोरी है कैश मेमोरी कितना हुआ
Cache memory 16.
16 KB, sir.
16 KB.
व्हाट इज माय ब्लॉक साइज
256.
256.
BS means diversion or block size
Sir, block size.
देखना BSR मत लगा देना ठीक है so this is given to me okay now what is main memory 2 to the power 7 into 2 to the power 2 to the power 10 can I write
Yes, sir.
then 2 to the power how much
17.
so this is my main memory address size clear
Yes, sir.
clear this part 17 now you know block size is 256 byte it means 2 to the power how much 8 clear here I considered that individual location is 1 byte addressable okay 1 byte it's a byte addressable memory location okay individual size is 4 byte or 6 byte it is not mentioned byte addressable memory location okay individual size is 4 byte or 6 byte it is not mentioned here so if it is individual location 4 byte addressable then I have to again divide the block size with that byte addressable word size here it is not mentioned so don't worry directly block size so I will consider block offset is byte addressable that means word size itself individual location of the word is 1 byte so 8 bit for is offset that means location 256 will be there any individual location it will be like in this 8 bit combination individual location are you getting my point within the blocks clear so here 8 bit is fixed this for block offset now this is what bn means what block number clear that is our main memory location this part up to clear or not clear tell me
Yes, sir.
so how many this size of main memory will be there that is 2 to the power 9 how we did find out main memory size divided by block size it will get the number of blocks that is the number of blocks in main memory clear not clear
Yes, sir, clear.
नहीं
Yes.
बहुत को क्लियर नहीं हुआ किसको किसको क्लियर नहीं हुआ आ जाओ बेटा अदिति अदिति क्लियर देवलीना देवलीना enjoy the class no problem Vikas Kumar
Yes, sir.
or Devolina
Yes, sir. My mic was not working.
now how it is working
Sir, I couldn't find the options. That's why.
acha now it is you understood the point
Yes, sir.
acha see I am asking some question and there is a chance that you try to create the impression on me you know up to final year this the person is the very very intolerable person from your side. So try to enjoy the classes. At least response promptly, that's sufficient for me. Shubhadeep Rudra or Subhash Rudra. Shubhadeep.
Yes, sir.
Shubhadeep Rudra, understood?
Yes, sir.
Vikas Kumar, out. Very good, no problem. Saptarshi,
Yes, sir.
बेटा क्लास में तो मैथमेटिक्स आएंगे. अगर आप यस हो गया तो आप कैसे सॉल्व करोगे? क्योंकि ओपन बुक एग्जाम होगा, मुझे मालूम है. सॉल्व तो तुमको खुद करना होगा. हर्षित सुराना,
Yes, sir.
क्लास में हो?
Yes, sir.
अच्छा अच्छा, पबजी नहीं खेल रहे हो तो?
No, no, sir.
अच्छा, साइड में चलते हैं कभी कभी. ऋषिकेश, ऋषिकेश, ऋषिकेश का हाल बहुत खराब है. उत्तराखंड में बहुत बाढ़ आया है, वो भी ऋषिकेश में आया है. ऋषिकेश बेटा अभी हो या धरती पे? बेटा एंजॉय करो, नो प्रॉब्लम. महादेव,
Yes, sir.
अच्छा, अंडरस्टैंड?
हाँ सर बुझे. Yes, sir.
कौन सा? हाँ, कौन सा अंडरस्टैंड करने के लिए मैं पूछा?
सर
क्वेश्चन बताओ.
जीरो. हाँ.
क्वेश्चन बताओ. How did you get the
Memory
block
location
size 9 bits? You clear? Aditya Gupta,
Yes, sir.
आदित्य, हाँ, अंडरस्टैंड द पॉइंट.
Yes, sir.
ए आदित्य, तुम्हारा वीडियो ऑन करो. आदित्य वीडियो ऑन करो. अरे बाबा, बढ़िया बात है. आदित्य कहाँ पे हो? घर पे हो?
हाँ
अच्छा अच्छा, कहाँ पे तुम्हारा घर है?
सर बैरकपुर.
बैरकपुर. ओके ओके, thank you. Now you can switch over video to save the bandwidth. I will directly go to Abdul Alim. Abdul,
Yes, sir.
okay, understood?
Yes, sir.
Okay. Oishik Bhattacharya. Oishik, everything I am noting in the copy. The delay from your side. Oishik Bhattacharya. Very good. एक मिलाज. ठीक है, एंजॉय करो, नो प्रॉब्लम. So up to this point is clear. Number of blocks size to the power m. So 9 bit will be required for our main memory purpose. So total was 17. 8 is minus, automatically 9 bits. So 9 bit for our block size. Is it clear this part?
Yes, sir.
Okay. Since 9 bit you have got, now what is our target? Our target that 9 bit, now main game is coming into 9 bit. 9 bit we have to separate into cache line and tag. Okay. Significance I'll come. What is tag? Why significant? I will explain. So 9 bit, how many cache lines will be there? What is the cache size? 2 to the power? What is the cache size?
16 KB
16, sir.
16 KB. That means 2 to the power 10 into 2 to the power 4. Na?
or 4.
What is the
Yes,
block size? Block size should be always same for cache and main memory. At a time, one block will be loaded to the main memory to cache. So block size is 2 to the power 8, 2 to the power 2, 2 to the power 6. Am I correct?
Yes,
Yes,
sir.
sir.
So this is in the cache. Total number of block cache lines to the 6. So 6 bits is required for cache. Total 9. What is the tag size?
3.
Clear? Clear or not clear?
Yes, sir.
Sir, can you repeat again once more?
Total 9 bit from the main memory I have counted. That 9 memory block will be mapped to the cache. So cache has a cache line and tag. So cache line will be number of the cache size divided by the block size. You will get the total number of cache lines. number of cache lines. Number of cache line equal to cache size by block size. CS by BS. कंप्यूटर साइंस को BS हमेशा तोड़ देता है, इसलिए computer science by BS. You will get the number of cache lines. Got?
Yes, sir.
So 6 bit for cache line. Total 9. How many bits are there for tag?
3 bits.
Three. If tag 3, it means that for particular tag bay is required for comparing the data. Now I'll come to the our theory that in these cases, okay. I'm sharing the other slides, so you'll again come to the point. So we are in there. So what is the tag bit now? 3. Am I correct or wrong?
Yes, sir.
Yes, sir.
Yes, sir.
So 3 bit is required for entire cache size. What is the cache size? 2 to the power 6, because 3 for individual locations, 3 tag bit for individual locations of the cache. Am I correct or wrong? 2 to the power 6 number of locations are there in the cache, and 3 bit for individual one location. So how many tag directory size? 3 into 2 to the power cache size. Is it clear? Not clear?
So why 2 to the power 6, sir?
How many cache lines are there?
Cache line 2 to the power 6.
2 to the power 6. For each of them 3 bit required. So how many total tag directory size will be there? 3 tag bit for number of total cache lines. Because for individually or each of them cache, their tag bit is used. Okay. So let's go to the previous slide. This is the cache. I am telling that this is the tag. Okay. Suppose you are searching some page. Okay. I need some animation. So that's why I am skipping this slide and come to the point. A PPT will be open. Just 1 minute. Some PPT is required to open here. How direct mapping takes place. This is a very important point. Try to understand, because if it is not clear, then rest of the part will be a very big problem for us. This is clear. Direct mapping I have written. So it is that found how many block lines are there in the cache?
4. Total.
4.
4 lines.
Yeah, 4 lines are there. You just point to be noted that total 16. I think total 16s are there, na? Oh, sorry. Total 16. क्या होता है मालूम नहीं, पीपीटी में बहुत प्रॉब्लम होता है. Okay, just try to understand. Total 16 locations are there. 0 to 15, 16. Okay. How many bits is required for the main memory block here? Tell me.
4.
4. Any 4 bit can 000 will specify this one, 001 for 1. That means you have 4 bit main memory location. What is the main memory size? If I consider individual byte addressable, so each of them 4 KB, 4 byte. Individually 1 byte. In earlier it was 256. That's why how many bit required? 8 bit. Here 4 location. How many bits are required?
6 bits.
4 locations are there. 1, 2, 3, 4. 4 location.
2 bits.
2 bit. 2 bit is sufficient to access. So offset size is 2 bit. Offset size is how much? Block offset size is 2 bit. Okay. And block offset within the block to access any of the block. Within the block to access any of the individual byted word, you need 2 bit, and using this 2 bit, and here is how many bits are 4 total, how many bits are there, then S plus W. S is the main memory's source searchable location, that is 4 bit. Is it clear? Kadam, it is clear. Karam, it is clear?
Yes, sir.
4 bit for individual main memory location, because here 16 locations are there, so you have 4 bit, and individual location 2 bit, so 4 plus 2 6 bit, so total memory size is actually 2 to the power 6. 2 to the power 6 how much? 64. If it is byte, 64 byte. So this is the main memory location you are estimating from the block diagram also, 64, and that's why you see 0 to 64. It is clear? This 63 means 0 to 63 means 64. So 64 total blocks are there in this byte decimal location. Since block size is 4, so 64 address location divided by the block size. How many block will be there? 16?
16 blocks.
That's why I see 0 to 16. Is this point clear or not clear? Tell me first.
Yes, sir. Okay.
Yes, sir.
आज तो एंटेना गुम हो जा रहा है क्या? एंटेना को पावर लगाओ. First I am telling, here you find that block offset size is 2 bit, and main memory you can search 4. So you find 2 to the power 4 plus 2. That means 2 to the power 6. That means 64. Since block size is 4, 64 by 4 how much? 16. Interestingly, this is there 16 locations are there up to 15. 0 to 15, 16. So this is the number of blocks. How many blocks? 16 blocks. Is it clear? Now,
Yes, sir.
among the 16 blocks, our target that each of the block will be loaded to the particular location because it is direct mapping. How we have to find out? Now go to the cache memory. How many cache size here is given? 1, 2, 3, 4. 4 is the cache size. Okay. And divided by the block size. Total cache. Actually, I don't know what is the block. If you consider the line number, is the 4 lines are there. So among the 4 lines, because block offset will be same. So any one full block will come here. Our target that 4 bit I have to split. That 4 bit I have to split in the tag and cache line. How many cache lines are there? 4 lines. 4 lines mean 2 to the power 2. Any one of the line can be accessed using how many bits? 2 bit. Am I correct or wrong? Any one of this line can be accessed by using 2 bit because 4 blocks are there. That's why 2 bit for line and remaining bit 2. 2 for tag. Why tag? Actually, whenever a page is searched, particularly you will find that it will first go. Suppose I am searching these pages. CPU searching these pages. Clear? Now you have to separate from the page block offset and block number. Why it is 4 and why it is 2, it is clear. I have just part the block offset and block number. Is it clear or not clear this part?
Yes, sir. Clear.
Clear, because you know the main memory size is 4, number of main memory blocks 4 bit and 2 for block size. It is already offset mentioned. So now our target that this will be searched. Now it will search from first 0 location, automatically it will go 1 by 1 location. So it is found this location because this decimal value is 1. Now it is go to the location, is a decimal value is 1 and block side, so it is got that location. Is it clear? So it is finally got that location. Clear? So it will go to the location. Now after that,
Sir, one confusion, sir.
Yes.
Sir, I have one confusion. Sir, formula for the cache line, you have tell that cache memory size divided by block size.
Yes.
Sir, then here it will be cache line will be 16 or 4?
16. 16
Sir, here
is the
cache
no, no,
line is 16.
cache line, not cache size is 16.
Okay, cache size is 16 and
Divided by block size. Block size is 4.
yes, sir.
Then how many cache line will be there?
So 4.
Okay, understood.
Yes, sir.
Okay, no confusion should be there. Now I am searching these pages. I found this is not available in the cache. That's why I'll go to the main memory. I found in the main memory, and which location this. So block number 5 should be loaded. Now block 5 will be loaded. What is the number of line size? 4. 4 or not? 4. So 5 divided modulus with 4 line size. What will the value is coming?
1.
1. It should be loaded 1, or I have to divide this value with 4. Tell me. Which one? This one or this one? Most interesting is that you had got this page here. That does not mean that you will load only this. You will load entire block. Can you tell me why? Because this block contains your page, and I will load this entire page in the cache. In which location? You take the block number divided by the cache line number. How many cache line is there? 4. What is the block number value? 1. 1 modulus 4. What is the value? 1 or not?
1.
1. So this block will go here. But my requirement only 5. But I am telling that I will load this entire block. Why? Block size is same. I can load it entirely. But my point is that since I know only 5 in the block, within the block only the block number 5 is my required goal. Why I am loading 4, 5, 6, 7 together in the location of 1? Here you will find 4, 5, 6, 7 will be there. Can you tell me why?
So due to locality reference.
Yes, that is a very good answer. Who has given the answer? Very good answer. So, Bonali, na?
Yes, sir.
Okay, appreciable, because this is the specialty locality reference concept. I know 5, but near about there is a chance I can access 4 or 6 also. But that's why I'm telling the block size of the cache and block size of the main memory should be always same, and that should be loaded accordingly. So entire block will be loaded, not partly block we are loading. I am not loading the entire main memory, but when I am loading, I load the entire block. That is my question. I am not loading the entire. I am not loading the entire main memory, but when I am loading a block, I load a block fully. That's a 4, 5, 6, 7. Even my requirement is 5. At this point 5, but there is a chance to get the 6
So
also.
you're not audible, sir.
I am not audible.
So now you're audible.
Okay, I am checking it. Now is okay.
Yes, sir.
Yes, sir.
Certainly, I become very excited about the hard answer that you have given promptly. Then thanks, Bonali, is nicely answered. That means something you are learning and you are expressing the view. It gives me an encouragement. Okay, you understand? Go, hurry. I have to finish. The already time is up. So anyhow, you find that these are the possible locations we are getting like in this way. So Bonali, you will get one Diwali Bonaja. Thank you. I am asking a lot of questions, but critical answer is the very appreciable one. So issue is that here you will get, or in all these cases, particularly see individual for 3 locations, individually for number block 7. You just see that block numbers. The decimal value automatically points to the which block is present. Clear? And these offset value in the day at that location, if you divide in 4 location, actually by using these blocks offset, you are accessing this location. And here is the among these 4 location, you are accessing this location. Is it clear? Like in this way. Now, Among the box size, you have to break the cache line size. That's why I'm telling you. Now, among the block size, you see these all have same cache line. Number 3, 7, 15. Interestingly, you see that 3, 7, 15 all will go particular single location or not? Because block 3 divided by 4, it is again 1, 7 divided by 4, it is again 3. Am I correct or wrong? If you go 3 divided by 4, oh, 3 divided by 4, 3 remainder 4, sorry, not divided by remainder 4, it is 3, 7 remainder by 4, it is again 3, again 15 remainder by 4, again you will get this 3. So all are location 3, and see, interestingly, all the cache line value is 3. Am I correct? Because main memory block segregated in the two part, cache line and tag line. So cache line, 4 lines are there, block size also 4. So 2 to the power 2 bit is required for the each number. So from the main memory, if you segregate these 2 lines, you will get it automatically. Clear? So accordingly, it will be stored. After that, you will go to this concept cache line. Now, if you are searching like in this web page, within the page, this is our cache line and block. So you can say it is the main line, and this part is the offset. Now you notice that if you see this part, I am segregating, and each of them have same cache line 0 0 0 0 0, but their block set is differ, block offset differ. That means all will go to the location here, their location here. So among them, they will individually take each of the locations. Is it clear? So you will find that initially tag is compared. This tag bit is compared with the cache tag bit. Okay. So what is the tag bit significance? Tag bit will help you to identify that whether this acquired block is present in the cache or not. Tag bit will identify you that whether it is present or not. That means first you have to go to the block. You should go to the block. How you can go to the block? Using the cache line number. It is 0 0. So go to the block. Now compare its tag bit with the available tag bit. Sometimes there may be 0 1. It does not mean that 0 0 class tag bit is 0. Here it will indicate that this page is present. Since it is 0 0, I can say this page is present here. Are you getting my point or not? First of all, when a page will be loaded to the main memory to the cache, so that time it may happen that initial cases directly it will go loaded and this tag bit will be updated. But next time when you are searching in the cache, first from the address location, it will take the cache location, cache line number. According to the particular cache line, it will go. After going to the cache line, each tag bit I will compare with the tag bit of the available memory. If it is matches, I can say it is present in the cache. Otherwise, it is not present. Is it clear what is the significance of the tag? Can you tell me what is the significance of the tag?
So to check whether it is in the cache or not, existence within the cache.
But whenever any CPU address generated, that time first what you will do? By using the tag cache line, I will directly go to the particular cache. Clear? Reverse way thing. As my policy, cheating policy user, remember, whenever you are searching particular page, you first check the cache line number. That means you segregate the block offset part, and from the main memory part, you take the cache line part. This is the cache line. So from the cache line, you will go. These pages all have 0 0. All are 0 0. So they will occupy the first location. Is it clear? Now, among this page, can you tell me which page is present here? Because you know the tag bit is there 0 0, and among all these things, whose tag bit will be compared? Can you tell me all these pages has tag bit how much? 0 0. That means they should be available in this location, not in any other location. Is it clear? So this entire block is actually, this entire block means this one. I am written shortly, but this is be loaded in these cases. Clear? That's what tag bit matching. So I can say this is this block, but here it is not matching. So this is not matching this location. Even you see they have also same cache line. Am I correct or wrong? Their cache line and their cache line is same or not?
Yes, sir.
Yes.
Same.
Yes.
But when I compare the tag, I found this comp tag is not matching with this tag of the available. So I can say among these two, which block is present?
The first one, sir.
Last one, block 0. Though block 0 and block 12 can occupy the same location, but how can I identify which block is present? Because at a time one block will be present. Is a direct mapping. Is a direct mapping. I can't allocate 12 any other location. Only particular location I'll go. So that's why it is found that tag bit will compare and then it compare among 0 and 12 which is present. Because I know 0, 4, 12, 16 all should be there. 16 is not there. So 0, 8, 12, 0, 4, 8, 12 should be there. By tag you can understand it. Is it clear? So this is the significance of the tag as well as the purpose of the block. So that's I have again mentioned here. Here tag will be compared. So how many compare is required here? How many compare is sufficient in hardware prospectus?
2 compares.
Tell. Whenever you are searching, suppose a page in the cache, so it will go to the multiplexer. I will discuss this architecture later. Now it will be tough for you because today I am stopping it here. Okay? It's okay or not?
Yes, sir. We have class at 3. 2
Yeah.
minutes.
Okay. Take the break. Tomorrow I will start from this part. You understood today's concept?
Yes, sir.
Yes, sir.
Okay.
Yes,
Thank you.